I1 Z11 plus I2 Z12. V2 is equal to I1 Z21 plus I2 Z22. So this is Z11 is equal to V1 by I1 when I2 is equal to 0. Z12 is equal to V1 by I2 when I1 is equal to 0. Z21 is V2 by I1 when I2 is 0. And Z22 is equal to V2 by I2 when I1 is 0. Yes. Now tell me, what is your doubt in this? Saying you are having some doubt in this?
Actually, there was no doubt, sir. Like
Hmm.
while you were writing that, yeah, I don't know how I got quit.
Oh,
Then I had,
you got quit. Okay.
uh,
Acha, I didn't see you then. Okay, I was continuing the class. Okay.
I was
Yeah.
actually again. I quickly I joined, but I had to just mention that in group so that I could join again.
Okay. Acha. Okay. Yeah. Anyhow, so this is what I was telling you. These are called as Z parameters. Okay, or also called as open circuit parameters. Why? Because you're open circuiting the current what we call port 1 or port 2. I1 0, I2 0, in the sense current 0 is an open circuit condition. That is why these are called as open circuit parameters or Z parameters. Okay, or impedance parameters. Okay. So
Please show the difference between like a symmetric and reciprocal network in a small circuit.
I didn't understand. Can you repeat?
So a symmetric network and reciprocal network.
Uh,
We can
yeah,
show a small diagram so that it will be.
I was writing here and it got erased. I wrote here. I think you didn't miss it, right? The definitions.
Actually, I didn't see
Okay.
the diagram, I
Okay.
think.
Okay. Anyhow, you'll understand it here. Okay.
Okay.
So these are what I call it as. This is open circuit input impedance. Okay. Input impedance. What is this called? This is called as open circuit. These two are called as open circuit transfer impedances. Transfer impedance, because V1 by I1, V2 by I1, not of the same ports, right? That is why these are called as transfer impedances. And this is called as open circuit output impedance. Okay. See, the circuit is said to be symmetrical when Z11 is equal to Z22. That means V1 by I1 ratio is not changed even if you change the ports. Okay. Even if you change the source and excitation, V1 by I1, the ratio is same. Then you call them as symmetrical networks. Symmetrical networks. Okay. Z12 is equal to Z12 is equal to Z21, then you'll call it as reciprocal networks. Reciprocal networks. Okay. Z12 transfer impedances are, the ratio of transfer impedances are same, then you call them as reciprocal. Reciprocal means the ratio of response to excitation is invariant if you interchange the positions of excitation and response of the network. Okay. Then you'll call them as reciprocal networks.
Okay.
See, I was telling you about the T equivalent circuit. So this is Z12. Okay. Z11 minus Z12, Z22 minus Z12. Okay, and this is valid only for reciprocal networks. That means Z12 is equal to Z21. Okay, this is my V2, this is I2, V1, I1. Okay, so you have to remember this. Okay, whenever you see a T network, if some resistance values are given, you should be easily able to find the values of Z11, Z12, Z11, Z12, and Z22. Okay, the values you should be easily able to find the T equivalent. Okay. Okay, is that clear?
Clear, clear.
See, and there is a general equivalent circuit. This is how you'll draw it. So this can be drawn like this. This is V1. This is V2. Actually, these are important. You'll get direct questions from this. Okay. Plus minus V1, I1, plus minus V2 and I2. Okay. You have to remember the what you call parameters. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Okay. So from this, if you see what kind of sources are this is a voltage component. Okay, so this I can call it as, this is directly proportional, so this I can call it as Z11. Okay, V1 is, if I write down the equation, loop equation here, V1 is equal to I1 into Z11, then this should be Z12 I2. This is a dependent voltage, so Z12 into I2. Z12 into I2. It depends upon this current and the values Z12. Okay. Similarly, if you see from this side, so V2 is equal to Z22 I2, Z22 I2, and this will be Z21 I1. So this is a dependent voltage source. What kind of dependent voltage source? Sorry, what kind of voltage source is? Current dependent voltage source, right? Current dependent voltage source. Okay, this is the general equation, general equivalent circuit of a Z parameters. Okay, understood how I draw this? V1 is equal to Z11 I1. Okay, you'll have to get this equation from the circuit if you write down the mesh analysis, loop equations. Okay.
Clear.
Next, you have something called as admittance parameters. What are admittance parameters? Again, see, this is my two-port network, plus minus V2, I2, plus minus V1, I1. Now, what I have to take? I have to take I1 and I2. I have to write them in terms of voltages and admittances. This is Y11 V1 plus Y12 V2, Y21 V1 plus Y22 V2. Okay. This is what you call admittance parameters. You can write them. Two is equal to Y11, Y12, Y21, Y22 into V1. Okay. This can be written as I is equal to Y into V. I is equal to Y into V. So from this, I can write again. Let me write down this. I is equal to y11 v1 plus y12 v2. I2 is equal to y21 v1 plus y22 v2. Okay. Again, if I write down this, y11 is equal to I1 by v1 at v2 is equal to 0. Similarly, y12 is equal to I1 by v2 at v1 is equal to 0. y21 is equal to I2 by v1 at v2 is equal to 0. y22 is I2 by v2 at v1 0. Okay. So when v2 is 0, v1 is 0, voltage 0 is a short circuit condition. So these are called as short circuit parameters or Y parameters or admittance parameters. Short circuit parameters, Y parameters or admittance parameters. Now let's define this Y11. What do you call Y11? Z11 is called as open circuit input impedance. Now this is called as short circuit input admittance. Okay, short circuit input admittance. These two are called as short circuit transfer admittance. Okay, short circuit transfer admittance. This is called as short circuit output admittance. Okay, short circuit input impedance, short circuit transfer impedance, sorry, admittance, and short circuit output admittance. Okay. So we have written the T equivalent of Z parameters, right? You'll have pi equivalent. Okay, pi equivalent of the whatever pi or delta. Call it as delta. Pi or delta equivalent of you call and admittance parameters plus minus v1 plus minus v2. This is my I2 and this is I1. So again, this is minus y12 minus y12. This is y11 plus y12 y22 plus y12. Okay, y22 plus y12. In case of Z parameters, what is the difference? You will get what you call this is my T. The T will be Z12. Here Z11 minus Z12, Z22 minus Z12. This is T and this is pi. So simply these all are what you call you can get these in terms of duality. Z parameters and Y parameters are dual of each other. So what you can say, you can write down the dual of one and you'll get the other. Okay, write down the dual of one, you'll get the dual of other. Okay, so T and what you call T and pi are dual of each other, right? So this is how you'll get it. Okay. So general equivalent circuit. So if I want to draw the general equivalent circuit, again, let me write down the equations first. I1 is equal to y11 v1 plus y12 v2 and I2 is equal to y21 v1 plus y22 v2. Now, what I can write? Just reciprocal of the sorry, dual of the previous one plus minus v1 v2 I1 sorry I2 and this is I1. Again, this current is getting divided, so this should be a parallel circuit, right? Current is getting divided, so this is y11 v1. Okay, y11 into v1 is the current here Okay, plus the second one is current. Again, it should be a leaving current, leaving the port. So it should be Y12 into V2. This is a dependent current source whose value depends upon the voltage here. So similarly, this will be Y22. This is leaving current Y12 V1. Okay, clear? This is called generalized what you call circuit, generalized circuit for Y parameters. This pipe network of a Y parameter. Okay, generalized equivalent circuit. Okay, and remember the T and pi will be only for reciprocal cases. That means Z12 equal to Z21 and Y12 is equal to Y21. Okay, condition for reciprocal and symmetry. Symmetry Y11 is equal to Y22 is symmetrical network, and Y21 is equal to Y12 is reciprocal. Okay.
Okay.
Next, let's see this. Find Z parameters for the following. Find Z parameters for the following. Just try to do this. Z parameters for the following.
Sorry, sir, I can't see anything.
You can't
See, like it's a blank screen. Okay, okay. Now it's
now.
clear.
Okay. Okay.
Okay.
See, find Z parameters for the following. The first one. Tell me directly. Z parameters in the sense Z11, Z12, Z21, Z22. For the first one.
60,
Hmm?
60.
Okay. Z12 is directly, right? These two, add these two. 20 plus 40. Okay. Is 60. And Z22, add these two. Okay. 70. This is the center one, 40 and 40. Okay.
Okay,
The
okay.
T equivalent, right? T equivalent. Remember, what is T equivalent?
Reciprocal, right, sir?
Yeah, Z12, Z11 plus Z12, Z12 plus Z22. Sorry, minus. I'm sorry. This is what I said. Z11 minus Z12. Okay, see, this is Z11 minus Z12. This is Z22 minus Z12, and this is Z12. So from this, I want Z11, Z12, Z21, Z22. Okay. So directly, what is Z12? 40 ohms, 40 ohms. Z11 is nothing but 20 plus 40. Okay. 20 plus 40 is 60. And this is 30 plus 40 is 70. Okay. Or how can you, if you don't know the shortcut, how do you find it? This is my 20, 30, and 40. Okay. So what is Z11? Z11, or you should remember this, V1 is equal to I1 Z11 plus I2 Z12, and V2 is equal to I1 Z21 plus I2 Z22. From the Z11 is V1 by I1 when I2 is 0. What is I2 0? I2 0 is an circuit, the input impedance. when this is open circuit, no current flows through this. Directly it is 40 plus 20, 60 ohms. Okay, so Z12 is again V1 by I2 when I1 is equal to 0. So when I1 is equal to 0, what happens? This is open circuit. Okay, this is how the circuit will become. This is my V1, this is V2, 30 and 40. Now what should I, V1 by I2, I want V1 by I2. What is V1 by I2 here? This is the current flows, I2 is flowing here. So V1 by I2 is directly 40 ohms, right? Similarly, Z21, V2 by I1 when I2 is equal to 0. So the circuit will be something like this. You're understanding, or am I going fast?
No, I'm understanding well.
Okay, this is I1, this is 30, sorry, 20 and 40. So again, what is V2 by I1? 40 ohms. Okay, Z22, again, V2 by I2 when I1 is equal to 0. When I1 is equal to 0, this is a circuit. I1 is equal to 0, V2 by I2, you'll get 70. This is the total impedance. Okay. Next, the second one. For this, tell me Z11, Z12, Z2. You have the T equivalent again. Remember, this is Z12, Z11 minus Z12, Z22 minus Z12. So in this, what is missing? See the circuit, the second one, the term this is missing, right? Z22 minus Z12 is equal to 0 here. So Z12 is, okay. Is it clear? Z12 is again your 12 ohms, Z21 12 ohms. What is Z11? Z11 is 16 plus 12, which is 28. Okay, what is Z22? Z22 is
12. 12. So I think the other way is easy for me, I think.
Hello?
Hello, sir.
Yeah, am I audible now? I don't know, suddenly it got disconnected.
Okay. That's where I got hosted. So I will make you host.
Okay.
Okay.
Okay. Able to see the screen?
Yes, sir. Yes, sir.
Yeah. So I want Z11, Z21 and Z22. So tell me, what is Z11? So you have to compare with the T. This is Z11 minus Z12, Z22 minus Z12, and this is Z12. Z12 and Z22 are same, 12 ohms. So this is 28, this is 12. Clear?
Yes, sir. I think the other way is easy for me. That formula.
Which formula?
I mean the equation. Like V1.
Yeah, the equation you can do anytime, but this is a simpler way.
Okay.
Isn't this? It's a similar way. It's a easier way, right?
I don't know. Maybe for me.
Okay. Because see, if you remember this T, it will be beneficial in many ways. Because I'll tell you, I'll tell you in a minute about this. But if you remember this is very easier. Okay. See, and Y parameters and Z parameters are inverse of each other. Okay. Okay, y
Okay.
inverse is Z parameter. Okay, the matrix Y is Z in or Z is equal to Y inverse or Y is equal to Z inverse. If I want Y parameters for this, write down the Z parameters matrix and just invert it.
Okay. Okay.
Okay, that there are like many shortcuts you can use. So tell me for this one, 4 ohms and 2 ohms. Tell me the Z parameters.
Z11 is 4.
Mm.
Then
Z11 is 4,
4 other is
Z12
and Z21 are 4 ohm each,
4,
and
Z22
last
is
4 ohm each, and last one must be 6.
yes. Okay, clear, right? This one.
Clear, sir. Clear.
Yeah. Now find the Y parameters. Find the Y parameters. See, you have to remember the formula I told you. This is minus Y12. This is Y11 plus Y12. Y22 plus Y12. As simple as that. Okay. Y22 plus Y12.
So I think I have some problem in remembering some simple things because
Okay. Anyhow, see,
uh,
sometimes if
I
you
don't
practice.
understand how it comes. Then it's
Okay,
the problem.
you didn't understand how it came.
No, no, no. Actually, yes, yes. I didn't understand that. How this formula came.
Okay, see, this is as simple as this. So let me give you for the T1. Okay,
Okay, okay, sure.
I'll call this as ZA, ZB, and ZC. Find the Z parameters for this. Find the Z parameters for this.
By formula, it's a day
Use
plus
the
Z.
formula. Use the formula. Use the formula. Use the formula.
And ZB is not there for its
Z1,
first case.
sorry,
ZA plus ZC,
ZA, ZC, and ZB. Right?
which is
Okay.
open circuiting the second current.
Uh,
So ZA plus
so
ZB.
So Z11 is equal to V1 by I1 when I2 is 0. So open circuiting it.
ZA plus ZB.
What's happening? Why is it getting erased off the time?
Okay, okay.
Yeah. Okay, this is okay. So when you open the second circuit, this is how your circuit will be. This is Z minus V1 plus minus V1. This is I1. Okay, I2 is 0. Remember, the other circuit will be C ZB. Okay, this is plus minus V1 plus minus V. Okay, so this is when I1 is 0. This is circuits. Okay, clear so far? So now if
Clear,
I
clear.
want Z11, Z and the instance as seen from this. So Z11 is directly ZA plus ZB, right? ZA plus ZB, Z11 is. Okay, and what is the other? You'll get. Sorry, this is going out. Okay, so Z11 you got it as. Why it is getting this? This is ZB, right? And this is ZC. Okay, there are two circuits. ZA, B, B1, B2, Sada color, ZC, ZB, plus minus V2 and V1. Okay, this is when I1 is 0. This is 0. Okay, so again, as simple as that, Z11 is equal to V1 by I1 when I2 is 0, which is equal to ZA plus ZB. Okay, then Z12, what is Z12? V1 by, sorry, V2 by 1 by I2. Rather, I'll write it
V1
as
by I2. Okay.
yes, I understood. I want to write Z21 because I want to use this condition as I2 0 first, and I will write them V1 by I2. Sorry, V2 by I1. V2 by I1 at I2 0. Okay, from this circuit. Okay, from this circuit, V2 by I1. What is V2 by I1? V2 by I1 is ZB directly, right?
Right.
Okay, from this next using this one. Thank God it's not gone. Okay, using the other circuit, this one, what I'll do, I1 0 is Z12 V1 by I2 when I1 0. What is V1 by V1 by I2 here is equal to ZB, right? Then again Z22 is V2 by I2 when I1 0. What is V2 by I2 when I1 0? ZB plus ZC, right? Right. So now I have Z1 in terms of ZA and ZB. Okay, Z11 and Z21 in terms of ZB. Now I have ZA, ZB, and ZC. Now I have all these three. I want to write in terms of Z11, Z12, Z22, and Z21. Okay, so what can I write from this? Z11 is equal to ZA plus ZB is also equal to Z21 or Z12. Okay, Z12 or Z21. So ZA can be written as Z11 minus Z12 or Z21 because it's a reciprocal network. So this I can write as Z11 minus Z12. Similarly, this is equal to Z12 or Z21. Both are same, right? Z12 or Z21 both are same. Okay. And what is ZC from this? ZC is equal to Z22 minus Z21 or Z12. Z22 minus Z12. Okay, understood how I got this?
Okay.
So if you remember this kind of circuits, you'll encounter many times. That is why, you can directly write it in terms of Z parameters if you know ZA, ZB, and ZC. Okay. Similarly, Y parameters also. This is minus Y12. This is Y11 plus Y12. This is Y22 plus Y12. Pi network in case of Y parameters. Okay. So now I want Y11, Y12, Y21, and Y22. Tell me quickly. Find y parameters.
y11.
Y11 is, see what is y12? Y12 is -2 and this is -2. Okay, what are the units? Mo. Admittance, remember y12 and y21 is -1/2. These are in ohms, right? So this will be -1/2. Color got changed.
Oh, okay.
Okay, -1/2 mo. Siemens or Siemens. Okay, mo you generally use for what you call conductance, right? Mo used for conductance. In admittance you use Siemens. Okay, so -1/2 Siemens, -1/2 Siemens. Y11, what is y11 now? Y11 is equal to 4 minus y12. 4 or 1/4 minus 1 by right?
4
See
plus by 2.
what happened? What happened?
I think it's 1/4 plus 1/2.
Yes, 1/2. Okay, so y11 is 1/4 plus 1/2. It is
3/4.
this
3/4.
3/4. Okay, 3/4 Siemens. 1/2 plus 1/4. Y12 is equal to y21 is equal to 1/2 minus 1/2. Y22 is equal to 1/2 plus 1/8. Right? 1/2 plus 1. How much?
5/8.
Okay, 5/8. Okay, clear?
Clear.
So the next one, this one. Tell me the y parameters for this. So again, you can use the formula and do it, or find the z parameters. Okay, because it's a T network. Finding z parameters and finding the inverse of the matrix is simpler. Okay, or what else you can do? What else you can do? You can convert this star to delta. Right, star to delta, you'll again get in terms of pi network. Okay, remember duality.
Yes.
Okay, star to delta conversion, right? Star to delta, you can do it that way, or you can find the z parameters directly and invert it. Anyhow, you can do it any of the methods. Okay, or you can use the formula. I don't prefer using the formula because that the concept is like, you should understand the simpler. Try to do it in the simpler way.
I think formula means I1 equal to that case,
Yes.
taking each port.
Taking each port. That is how you can do it. Short circuiting the port 1 and short circuiting port 2, making V1 and V2 0. You have to find I1 by V1 and I1 by V2. I2 by V1. That is how you can do it. Otherwise, again, Z parameters, convert it in this one, directly Y parameters or directly Z parameters. Tell me Z parameters for this. Z1
That's
is
better, I think. Z parameters are
18.
better.
Z12, Z21 is
12,
12. Z22 is
30.
directly. You can write directly, right? So
Right.
inverting this 18. So invert this 1 by AD minus B minus.
I think taking out all the
You can
common
do it that.
factors.
Okay, then it will be easier,
3,
simpler,
3,
right?
4, 3, 4, 4, 10. That's better, I think.
Okay.
6 into 3, 4, 4, 10. No. 3, 4, 4,
Sorry, 5.
5.
Okay,
Yes.
na?
3, 4, 4, 5. I mean, 15 minus 16 minus 1 is determinant.
What happened?
Determinant is minus 1.
Determinant is -1, right? Okay. Okay, tell me the inverse of this.
That's just like a, I can't see that 3, 4, 4, 5, right? It's like a 5 minus 4 minus 4,
Tell me the
3.
inverse of this. Huh?
5 minus 4, 5 minus 4 minus 4, 3.
Okay. 5.
Oh, 1 second, 1 second. Oh, it's not 3, 4, 4, 5. So it's 11. The determinant is actually 11, sir. I just see the updated metrics right now.
Okay.
So the determinant will be 11, and matrix inverse will be 1 by 11 into 5 minus 2 minus 2, 3.
5 minus 2 minus 2, 3. Determinant is 5
1,
minus 2 minus 2, 3. Determinant is, how much is
1,
this?
1 by 11
Huh?
and 1 by 11.
Okay.
And into 6 is there also. We have,
And 6 by 11, right?
yes, sir, yes, sir.
This is how you'll find the y parameters of y. Okay.
Okay, okay. I think it's better than delta and star. Anyway.
It actually depends upon the values. If all the values are
Yes, yes,
equal,
yes.
it's that's why I told you the method. You can choose any of the method you want. Okay.
All right, all right.
Understood, right?
Please, sir.
See the impedance parameters Z11 and Z12 of the two-port network shown. Tell me. Try to do this one. See, how are you trying to do it?
I think open the second terminal
So again,
because
the harder way. No.
is that one?
Okay. Okay. Listen to me. So
Okay.
convert the inner delta to star. Tell me delta to star conversion. Denominator is same, right? So denominator is 2 plus 1 plus 1, 4. Okay, 2 into 1, 2 by 4. This is 2. Circuit. So this is 2, 3. Inner delta, this is 2 by 4 2. Okay. This is 1 into 1 by 4, 1 by 4. This is 1 into 2 is 2 by 4 again. This is 1 by 2. Understood? Delta to star conversion.
Yes, sir.
Now,
Yes.
if you can see, this is 2.5, 3.5, 1.1 by 4. Okay, 1 by 4 is nothing. 0.25. So, this is just, again, you directly got it in terms of T. Now, can you tell me Z11? Z11 is 2.5 plus 0.25, 2.75. Right?
Yes, sir.
Z12 is equal to Z21 is equal to
0.2,
0.25. Z22 is
3.75.
Any options? Z11 is 2.75, Z12 is 0.25. Okay, option A.
Yes, yes.
Option A is matching, right? So this is how you can do it. Okay.
Otherwise, I would have died by converting again and again. I mean,
No, that takes a lot of time, right?
Sure.
So this is a similar way. Okay, sorry, simpler way. Okay, you have to try, see, z parameters or y parameters. You have to try to convert them into t or pi network. Okay, t or pi network, you can directly write them. Okay. Many of the times in exams or like in competitive exams, you will be given easier way to convert them into t or pi networks only. Okay, that way you'll get the options. They just want to test your concepts, right, rather than making you to do all the problems, right? So
Sure.
always try to do it in this type. Okay,
Sure.
so again, this one, the value of transfer impedance z21. Try to do this. Rather, tell me, how do you want to do this? Any shortcuts?
Like that middle T network.
Okay, you can convert the t to pi. Okay, and
Yes,
again
so
convert
we'll
the,
get parallel. So the 2 and the upper resistant will get parallel, and
right, or what else you can do? See, this is again a delta network.
upper one can be.
This is a delta network. This is the
Yes, yes.
circuit, right? 2, 2, 4, and 2. Convert this into t. Sorry, star. I mean delta to star. Okay, this is a simpler way.
Yes, that's
See,
the simple.
that way you have to convert 2 times. This is only 1 time, right? So
Yes.
denominator is 4 plus 2 plus 2 is 8. Here, this is my circuit. So you always have to try to do it in this way. This is 2. This is divided by 8, and this is 4 into 2. Shit, man. So this is 2. Again, converting the inner delta. This is 2, 4, and 2, and this is 2. So this is my 2, and this you'll get as 4 into 2 is 8 by 8. 8 by 8 is 1. This is again 2 into 2. 4 by 8 is 1 by 2. Okay, this is 1. Okay, and the other one is 4 into 2 by 8 is 1. So this is 1, 1 by 2, and 3. So Z21 is directly 3 ohms. Okay, clear?
Clear.
In the given circuit, the two-port network has the impedance matrix Z equal to 40, 60, 60, 120. The value of ZL for which maximum power is transferred to load is dash. Try to do this. Try to understand the question. Okay, you are given what you call this Z Z parameters for this network, and you have this one here, and you have a load here. You have to find ZL for which maximum power is transferred to the load. That means, as seen from these terminals, you have to find Z Thevenin, right? Right? Hello?
Low, right?
right? So what? How are you trying to do this? How are you trying to do this?
Should open that V source from that.
Source open or short? It's a
I mean
voltage
short.
source.
I mean short. Sorry, sorry.
Uh, okay, short it. Then
So we will get I1 as 0.
okay,
So we will get a um,
okay, okay.
that
Let
transfer
let me give. No, let me give you a simpler way to do this.
V2 by
So
I2 at I1 equal to 0. Z22 is 120.
okay, okay. So that Z22 is 120. You have that, but there is a resistance here. Okay, let me give you. Okay,
Okay, okay.
so the best way to do such kind of problems is, see, this is a Z network, right? You have Z parameters for this. Can you write the T equivalent of this network?
Yes, yes, yes.
Yes. So write down the T equivalent of the network, and you have a 10 ohms again. And short this. Find the Z terminal here. As simple as this. Tell me the T equivalent. This is 60. What is 40, 60, 60, 20? 40, 60, 60, and 120. Right? So T
Right.
equivalent. Tell me this value. I'm sorry. Tell me this value.
Like taking 20 as common, I think. 2, 3, 3, and 6. Sir, could you just update with 2, 3, 3, and 6? I don't have anything right now because that's why.
What is 2, 3, 3, and 6?
I thought you talk about taking inverse, right, sir?
No. I said this is Z network, right?
Yes, yes.
Z equivalent. I know the T of this. See, if I have a T equivalent, can I write down the Z value?
Okay, that earlier you were told that that formula Z11 minus Z12.
Yes, this is Z11 minus Z12,
Okay, okay.
Z22 minus Z12, and this is my Z12. I have Z12 directly 60, so this should be equal to Z11 minus Z12. What is that? 40 minus 60 is minus 20. This is 120 minus 60 is 60. Okay, okay. Is that okay? Understood?
Yeah, I got it. I
Now
got it.
what? Yes, 10 minus 20 is minus 10, or if the values are what? Minus 20, 60, 40, 60, 60, and 120. Okay, let me see this. Minus 10 is in parallel with 60. I think I took some wrong circuit or the wrong values. Okay, anyhow, let
Actually,
me
it
take.
should. according to the metrics, minus 20 plus 60 should contribute to 40, right, sir? So
Yes.
everything is right according to the metrics also.
Everything is right, but there is a problem. I can't parallel minus 10 with 60. I'm seeing whether I have a different. Sorry, I think let me take this as 140 rather than 40. Okay. And then 40. I think I have written some numericals wrong. Okay, 140. Then how much will this be? This will be 80, right? 140 minus 60 is 80. Okay. Okay. See, the concept is important. Actually, I just want to show you that you can directly find Z Thevenin in this way. Okay.
Okay.
So 90 parallel with 60. Okay, 90 parallel with 60. So Z Thevenin is equal to 60 plus 90 parallel with 60. This is my Z Thevenin. Okay. This is simpler way to do it. I'm sorry I got confused with the numericals.
I got the approach, sir. That's enough.
Okay.
So it should be equal to the load impedance, right, sir? So
Yes, that should be equal to load impedance for maximum power. Okay.
Okay, fine. That's it.
Okay. See again. Consider the two-port resistor network shown when an excitation of 5 volts is applied at port 1. Port 2 is shorted. The current to
I cannot see the slide, sir, because still it's not updated. Okay. Right now it's updated.
Consider the two-port resistor network shown in the figure. When the excitation of 5 volt is applied across port 1 and port 2 is shorted, the current through the short circuit at port 2 is measured to be 1 amp. Okay. See this one. Okay. If now an excitation of 5 volts is applied at port 2, port 1 is shorted in the circuit, what is the current through the short circuit at port 1? Okay. This is the question. Answer? Any answer?
It's a reciprocal network, so
1 ampere
directly.
Okay. Yeah. Otherwise, what you have to do, you have to find the value of R, then substitute it here, then you have to calculate it. You'll again get the same value.
Okay.
Okay. Direct. It seems a bigger question. If you don't know the concept, if you know, it's direct answer. Okay.
Sure. I was also looking for any simple items. That's why this R has been same.
Okay.
Otherwise, I would have also tried to do that actually.
Yes. Okay. So again, I want you to try this as a homework. Okay, this is not a reciprocal network. Okay, this is not a reciprocal network. You have to find the average power delivered to RL in watts.
Slide is not updated.
Huh?
Slide is not.
Now,
Yes, yes. Right now it's updated.
Z parameters of the two-port network is given. Okay, the average power delivered to RL is 20 ohms. In the average power delivered to the load resistance 20 ohms in watts is dash. This is what you have to find. Remember, this is not a reciprocal network. Z12 is not equal to Z21. You can't directly write the T equivalent of the Z parameter. Okay, now try to find this. Okay, take it as a homework and you can try to do this. Okay, took a screenshot of it. Hello.
Yes, yes.
Okay. So try to do it and tell me if you didn't get it. In the next class, I'll tell you, or you can ask me in WhatsApp also. Okay. Next parameters are called as hybrid parameters. Okay. Next parameters are called as hybrid parameters. Hybrid parameters are also called as H parameters. Okay. Are also called as H parameters. Z and Y parameters for a two-port network doesn't exist always. That is why there is mix of Z and Y parameters. Okay, in Z parameters you have written currents in terms of voltages, right? Sorry, voltages in terms of currents, and in Y parameters currents in terms of voltages. Here you'll be having mixed. You'll write V1 and I2. V1 will be H11 I1 plus H12 V2, H12 V2 and H21 I1 plus H22 V2. Okay. Okay. So again, if I define H11, H11 is equal to V1 by I1 when V2 is 0. Next, H12 is equal to V1 by V2 when I1 is 0. Similarly, H21 is equal to I2 by I1 when V2 is equal to 0. Similarly, H22 is equal to I2 by V2 when I1 is 0. Okay. Okay. So what is this called? Voltage zero. Voltage zero is a short circuit condition. Short circuit input impedance. Input impedance. Okay. See, V2 is 0 again. See, what is this? I2 by I1. I2 by I1 is current gain. Gain, output by input is gain generally. So this is current gain. So this is called as V2 0 again, short circuit. V2 0 short circuit current gain or forward current gain. Okay, see, and again, sorry, I1 0 is an open circuit. So open circuit, what is this? Admittance, output admittance. Okay, this is also, what is this? Open circuit. What happened? Reverse voltage gain. V2 by V1 is voltage gain. So V1 and I2. H11, H12, H21, H22. Okay. So if you see H11 again, as I told you, this is V1 by I1 at V2 0. Okay, this is impedance, input impedance, V2 0 short circuit, voltage 0 short circuit input impedance, H21, this is H12 is reverse voltage gain, right? V1 by V2 at I10 is open circuit, so open circuit reverse voltage gain, I2 by I1 when V1 is 0, or sorry, V2 is 0. This is short circuit forward current gain, H22 I2 by V2 when I1 is 0, open circuit output admittance. Understood how I'm writing all this impedances, admittances, gains and all? So you have impedance, admittance, voltage gain, current gain, short circuit, open circuit, everything is there. That is why these are called as hybrid. Okay, H parameters or hybrid parameters. Okay, hybrid parameters are used generally. Where do you use this? These are used to model transistors, if you remember.
Right.
Right? Transistors, you'll use what you call hybrid parameters. Okay. So if I write down the equivalent circuit, this is I1 plus V2 plus V2, H11, H12, H21, H22. So this is something like this. This is a hybrid one. So you'll have this is plus minus V2, I2, I1, V1. So this is again a voltage source. This is H11, I1, and this is H12 and V2. It's a voltage dependent voltage source whose value depends upon this value. So this is again currents is getting divided, right? So current is getting divided. This is H22 and this is H21 I1. You are able to understand how I am writing this generalized circuit
Clear.
here, right? Okay. See, there is one more G parameters. G parameters are inverse of H parameters. Okay. What you call, I'll just write them. It's like I1 and V2. Okay, inverse of this, dual of this rather, not inverse, can say dual of this. So G11 V1 plus G12 I2, G21 V1 plus G22 I2. Okay, similar one. If I draw it, it will be like this. Here the current is getting divided, right? So here voltage is getting divided. So series circuit. So plus minus V2 plus minus V1 I1 I2. So this is plus minus G21 V1. This is G22. Okay, this is current value G12 V. Sorry, G12 I2. This is G11. Okay, these are G parameters and H parameters. Okay, G parameters are called as inverse hybrid parameters. Okay, so inverse of H is so why it got the name as G parameters is nothing. There is nothing. Only the term logic is after G you'll get H, right? Inverse of H you can call it as G. So that is in the alphabetical sequence. That is why you'll call them as G parameters. Okay, inverse hybrid parameters. Okay.
Yes.
So you find H parameters for this. Find H parameters. See again, conversion from Z to Y and Y to Z is simpler. You can even convert Z parameters to Z parameters to Z and Y also. But G or H parameters. What happens is you will get confused in remembering all those. Instead, if you are given something like this, it's easier to do with the formula. Okay, it's easier
Yes.
because this circuit is simple and it's easier to do it that way. Okay,
Okay. Okay.
so use the formula and do it. Okay, V20 short this. Okay, so this is I2, V1, I1. So V1 by I1 is H11. H11 is 6 and 3 parallel is 2, 2 and 2 is 4 ohms directly. Okay,
Yes,
then
sir.
I2 by I1, H21 is I2 by I1. Tell me what is I2 by I1? I2 in terms of I1. Current is getting divided. Current division rule. I2 is equal to opposite resistance is 6. Okay, total current is I1 by the total resistance. 6 plus 3 is 9. So this will be 2 by 3 I1. So I2 by I1 is 2 by 3. Okay.
Okay.
Next. The other thing is I10. I10 is open circuit. Open circuit, you won't get this. Here, this will be V1. Okay. And this is V2. And this is I2. Sorry. I2 by I1, I'll get minus, right? The direction is this way. Sorry. Okay. Okay. The standard direction of I2. Minus 2 by 3. Okay. Now, what else I need to get? So, is it understandable, right? Or shall I erase this? So V2, and there is no this one when I do I1 0. So now V2 by I2 or I2 by V2. I do I2 by V2, what I'll get? H22. H22 is 1 by 9. These resistances are in series. 6 plus 3 is 9. So 1 by 9 is H22. H22 is I2 by V2, not V2 by I2. Okay. This is
Yes.
Siemens, ohms, and this is current gain, no units. Then H21. H21 is I2 by I1. So what is I2 by I1? I1 and I2 are same, right? Sorry. No, H21 I got H12.
One, two,
H12 is V1 by V2.
by 9.
V1 by V2 is voltage division rule. V1
By
is equal to V2 into 6 by 9. Yes, 6 by 9 or 2 by 3. Correct. No negative. Plus 2 by 3. Okay. 2 by 3. H12 is 2 by 3. H parameters. Okay. Clear?
play, please.
Sometimes it's easier to use formulas, applying formulas. Sometimes it's easier to use what you call the conversions. Okay. Next, transmission parameters. Transmission parameters also called as ABCD parameters. Okay, transmission parameters are also called as ABCD parameters. These are used for transmission lines, hence the nomenclature. This usually this is my I2. So this I'll take it as minus I2. Okay. Okay. Transmission parameters, usually I'll be knowing the sending end voltages. I need to find the receiving end terms. This is my sending end. I'm sending, this is my transmission line. I know the sending end details. I need to find the receiving end details. Okay. Sending end and receiving end. So that means I know, or like, sorry, sometimes what happens, I can find the receiving end values, V2 and I2. I need to find V1 and I1. Either way. Okay. So transmission parameters are like this: V1, I1, okay, V2 and minus I2. V2 minus I2. So here A, B, C, D. Okay. I'll write V1 and I1 in terms of V2 and I2. Okay. V1 and I1 in terms of V2 and I2. So let's define each. A is equal to V1 by V2 when V, yeah, A is equal to V1 by V2 when I2 is 0. Okay. Also B is equal to what is B? Minus V1 by I2 when V2 is 0. Okay. Also C is equal to I1 by V2 when I2 is 0. D is equal to I1 by minus I2 or minus I1 by I2 when V2 is 0. So let's define this. What do you call this? Voltage gain or reverse voltage gain. Current 0 is open circuit, reverse voltage gain. Okay, this is V1 by I2 is transfer impedance. V1 by voltage by current is impedance. V1 by I2 is transfer impedance. Which transfer impedance? Voltage 0 is short circuit transfer impedance. Okay, this is transfer admittance. What transfer admittance? Open circuit transfer admittance. This is reverse current gain. What reverse current gain? Short circuit reverse current gain. Okay.
So actually, why are we using so transmission parameters? I mean, like
Transmission parameters.
H, A, B, C, D, and G, and lot of these are there. So why?
You can call them as A, B, C, D parameters or transmission parameters. Why in the sense, see, in transmission lines, especially in power systems and all, you'll be knowing the receiving end voltages. You'll be at receiving end. You'll have a transformer at your home or at a substation. You'll be knowing the voltage and current there, and you need to find the what you call sending end voltages and current. Or rather, you want a certain voltage and certain current at the receiving end, then what should be the sending end voltages and current? That you have to find. Okay.
Okay.
That is why these are called as transmission parameters, because you'll be knowing V2 and I2. Directly measure the voltages here and current here. You'll find voltage and current. And that is why the direction is this side, minus I2. Usually you'll take I2 in this direction. That is why my current direction is minus I2. Okay.
Right.
Similar to that of transistors. H parameters is used in transistors, right? So to what you call make them easy, we'll use it. Okay.
Okay.
See this ABCD parameters of a two-port network in figure. See, ABCD networks are very important in case of what you call transmission lines and all. Okay.
Can I take the screenshot of the last slide?
This one, right?
ABCD.
I take the picture of it. Okay.
Okay.
See again. They see this. Able to see this, right? The ABCD parameters of a two-port network is shown in the as shown in the figure. Are ABCD parameters are given. The output port is connected to a variable load. Okay. For maximum power transfer, find RL. Okay. For maximum power transfer, find RL. Okay. Again, you have to find the Thevenin's equivalent. Okay. Try to do this. Try to solve this. You have to find V2 by I2. Okay, Z Thevenin is V2 by I2. V2 by I2. Okay. With this as short circuit. See, how do you find this? See, for to find Z Thevenin, I need V2 by I2, right? And shorting this. Okay. Now this will be my V1. What is V1? And this is my I1. V1, I can write V1 as minus 10 times I1, right? Whatever the voltage drop across this 10 ohm resistor will be my V1. And the voltage drop is 10 into resistance into current. Current is minus I1 here. So this is 10 times minus 10 into I1. So replace this in this transmission parameter equation. You have V1 is equal to A into V2 minus BI2, right? A into V2 minus BI2, and I1 is equal to CV2 minus DI2. Okay. So I got A, B, C, D values 420.12. So this is 4 V2 minus 20 I2. This is 0.12, 0.1 V2 minus 2 I2. Okay, now I have to convert the entire equation in terms of V2 and I2. Okay, so what I can do, 10, this is a equation and this is another equation. So can you write one in terms of other? So V1 is equal to minus 10 I1, right? So minus 10 into I1 is here 0.1 V2 minus 2 into I2. Okay, or sorry, there is one more better way to do this. You have this. So from this V1 by I1 is minus 10. Okay, V1 by I1 is minus 10. V1 by I1 is minus 10. So divide equation 1 with 2. So V1 by I1 is equal to minus 10 is equal to 4 V2 minus 20 I2 by 0.1 V2 minus 2 I2. You can do it this way. So this is how you'll get 4 V2 minus 20 I2 is equal to 0.1 into minus 10 is minus V2 plus 220 I2, right? So this is what you'll get. 4 V2 plus V2 is 5 V2, 20 plus 20, 40 I2. So V2 by I2 is equal to how much? 40 by 5, 8 ohms. Okay, is it simple? Understood?
Yes.
V2 by I2 is 8 ohms. Or the ZL, sorry, RL. Okay, for maximum power is equal to 8 ohms. Okay, try to find this one. Try to find this one as a homework. Okay, so this is about two-port networks. I don't want you to do more of problems. Okay, that is why I'm not giving you interconnections and all. The concept you have to understand is how to write down the equations for all the parameters. Okay, Z parameters, Y parameters, H parameters, G parameters, ABCD parameters. Okay, clear? Clear?
Yes. Yes.
Okay. Okay, I'm closing the class now. Any doubts in today's class? The only thing is with what you call two-port networks, not only two-port networks, with networks in general is you have to practice more to get what you call concepts. Okay, concepts only you'll understand when you practice more and more. Okay. Okay. Good night.
Thank you, sir. Good night.